Hello, I am Karthik Vyas. I am a student at IIT Jodhpur. This is my project for AI course project, and in this I have to basically find out the most optimal path according to cost optimization in a grid from a given point to the final destination. I have described the details in the presentation video, that is another video. In this video I'll be running it over a few test cases and we will check that if it is optimal or not. So I'm going to run this running command, and we have been given three choices, that is to create a new grid, to use a default one, or to randomly create a new one. We are going to use a default one, and we can I have given these 7 default grids that can be used for testing. So I'm going to just run it over the third default grid. These grids are very good, and I have tried to cover all these cases, all the boundary cases, with the help of these 7 grids. So yeah, this is the grid, and we are at here and we need to reach here. The fuel capacity of the vehicle is 4, and the cost of one traversal in a plain road is 1, and in case of busy road due to and because of slow path is 3, and the amount needed to be paid at the toll tax station is 10. So initially we are here, and the fuel capacity is 4. So what our goal should be is to, as we can see in the third row, we need to traverse this, and there is only this one petrol pump in the second column. So to reach here we can use this path 0, 1, 1, 1, 2, 0, this and this, as this would also ensure a fuel check, and it does not incur any extra cost charges except for the traverse on a plain road. And from here we have to reach 2, 4. So we can either go with the path that is the bottom SSO, or we can go with OSOP. This is allowed us by the fuel check, since we are again reaching here at zero fuel capacity and we would have the refuel over here. So now we can go with the upper path, because there would you only need to traverse one slow path, but on the bottom of it we need to traverse two slow paths. So we will use this movement, and as you can see, from 2, 2 we are moving on to 1, 2, 1, 3, 1, 4, and 2, 4. So now we are here, and now we can see that if we use this path as of 3, 4, here and then a right turn, this would again incur no extra cost charges and would give us the optimal path. And the cost of the solution is 14. And yeah, so I think it is proved that this works fine. Let us try it over one more one more grid. Yeah, so let me again just use a default one, it saves a lot of time, and let me just run it over the 6th grid. Yeah, that is fine. Yeah, so here I can see that the other of the stats are same, but the fuel capacity is now my 3. So I can see that the only possible petrol pump for me to reach from here is only 3, 0. So I reach over here, and then from here I can either reach this or this, since this is more closer to the goal state. And we can say that if I reach, and I will need to traverse this, and from here there's again we will need to come over here only, so we can just directly propagate in the direction of the goal state. So from here we reach to the P, and to reach P we have two paths. One is this and this, and the other is this and this, and then this or this as well. So we choose the path that is from 3, 0. We choose 3, 4, 0, 4, 1, and 4, 2. So we first traverse over here, and then here, and then here. This is because obviously we want to we can see that the cost to traverse a slow road is 3, but in case to traverse a toll tax station is 10. So we choose this path, and this also proves that our functions are working fine, and we are only choosing the path that is the optimal. From here there's no point in going over here, so our goal would be to reach 5, 4, and we would need to traverse this S and T over here. So this would slow and this would toll tax, so but we have no other option, so we will use this over here. And as we can check as well, that in order to reach 5, 4 we have used 5, 2 and 5, 3. So that is also giving us the correct result. We cannot traverse from 4, 3, because that is a pit hole, so we cannot traverse through that. so it is working fine. And from here we can say that this is a very good path that we can follow, that is 5,5, 5,6 and 6,6, and it would not give us any extra result other than that traversing for the simple route. So the demo, it is working fine as of now. It is working perfectly fine, and this is the code, and I'll be describing the code a bit in the other video. And we are basically taking the input and through the three formats over here, and yes, and here is the priority queue, and this is basically ASA implemented, and we are using all of this, and making the addition to the cost functions and implementing it, and finally checking that if we have reached the goal state, then terminating it, and finally returning the goal call, the path along with the cost of the solution. Thank you very much.